Our solar system is a stage for a cosmic ballet. Planets waltz around the sun. Their partners, a diverse cast of moons, add to the spectacle. These celestial bodies, locked in a gravitational embrace, spin tales of cosmic history. Among the planets, Saturn stands out, a majestic giant with its iconic rings. Saturn, the sixth planet from our Sun, reigns over this diverse family of moons. This gas giant, composed mostly of hydrogen and helium, is easily recognizable by its stunning ring system. These rings, made up of countless icy particles, stretch thousands of kilometers wide. They are a testament to the powerful gravitational forces at play around Saturn. These forces, shaping the rings, also influence the orbits of Saturn's many moons. Among these moons, a small, icy world named Farbauti stands out. Farbauti, named after a giant in Norse mythology, is a small, irregular moon. Its diameter is estimated to be only a few kilometers. Like many of Saturn's outer moons, Farbauti has a dark surface, reflecting very little sunlight. This dark surface suggests a composition rich in carbon and other organic molecules. Farbauti's orbit around Saturn is retrograde, meaning it orbits in the opposite direction to Saturn's rotation. In the vast expanse of our solar system, new discoveries are always on the horizon. But finding these celestial needles in the cosmic haystack requires patience, ingenuity, and powerful telescopes. Such was the case with the discovery of Farbauti. In 2004, a team of astronomers led by Scott S. Shepard at the Carnegie Institution of Washington embarked on a survey of the outer solar system. Their mission was to search for faint objects, particularly moons around the giant planets. They utilized the Subaru telescope in Hawaii, one of the largest telescopes in the world. The Subaru telescope, with its immense light-gathering power and advanced imaging capabilities, allowed the astronomers to peer deep into the faint outskirts of our solar system. They meticulously scanned the region around Saturn, carefully analyzing images for any telltale signs of moving objects. After months of painstaking observations and data analysis, a faint point of light caught their attention. This point of light, barely visible even with the Subaru telescope, moved slowly across the background stars. The discovery of Farbauti, initially designated as S2004-S9, sent ripples of excitement through the astronomical community. It was a testament to the ever-evolving nature of our understanding of the solar system. The discovery was officially announced in May 2005, adding another member to Saturn's already impressive family of moons. Farbauti's retrograde orbit, moving in the opposite direction to Saturn's rotation, immediately set it apart from most of Saturn's other moons. This peculiar motion suggested that Farbauti was not formed in the same region as Saturn, but was instead a captured object. This capture scenario opened up a Pandora's box of questions. Where did Farbauti come from? Was it once an independent asteroid or comet roaming the outer solar system? The discovery of Farbauti and other irregular moons like it has provided valuable insights into the chaotic early days of our solar system. These captured objects, like cosmic fossils, hold clues to the processes that shaped the planetary systems we see today. In the early solar system, billions of years ago, the planets were still forming and jostling for position. The giant planets, with their immense gravitational pull, acted like cosmic vacuum cleaners, sweeping up smaller objects that ventured too close. By studying their physical characteristics and orbital dynamics, astronomers can piece together the history of planetary formation. Farbauti's dark surface, believed to be rich in carbon-based compounds, hints at a connection to the primordial materials from which our solar system formed. Farbauti, a denizen of the outer solar system, is a small world, even by lunar standards. Astronomers estimate its diameter to be approximately 4 kilometers, making it a mere speck compared to Earth's moon. This diminutive size makes Farbauti a challenging target for observation. Even with powerful telescopes, it appears as a faint point of light, its surface features remaining largely hidden from view. Based on its brightness and estimated size, astronomers believe that Farbauti has a very low albedo, meaning it reflects very little sunlight. This dark surface suggests a composition rich in carbon-based compounds, similar to other outer solar system objects. These carbon-rich materials, often referred to as tholins, are thought to be formed by the interaction of sunlight with organic molecules. While Farbauti's exact composition remains uncertain, scientists believe that water ice likely plays a significant role. This assumption stems from the prevalence of water ice throughout the outer solar system, particularly among the moons of giant planets. Water ice, in its solid form, behaves like rock at the extremely low temperatures found in the outer solar system. It can form the structural foundation of small bodies like Farbauti, mixed with other materials like rock and organic compounds. The presence of water ice on Farbauti has intriguing implications. While there is no direct evidence for such activity on Farbauti, the possibility remains tantalizing, particularly in light of discoveries of subsurface oceans on other icy moons like Enceladus and Europa. Farbauti's orbit around Saturn is a testament to the complex gravitational interactions that shape our solar system. Unlike most of Saturn's moons, which orbit in the same direction as the planet's rotation, Farbauti's orbit is retrograde. This retrograde motion, opposite to the general flow of objects in the solar system, is a strong indicator that Farbauti did not form in its current orbit, but was captured by Saturn's gravity at some point in the past. One possibility is that Farbauti was once part of a larger object that broke apart due to a collision or tidal forces. Another scenario suggests that Farbauti originated from the outer reaches of the solar system and was gradually drawn inward by Saturn's gravitational pull. Farbauti's retrograde orbit and distant location place it within a group of Saturnian moons known as the Norse group, named after figures from Norse mythology. These moons share similar orbital characteristics, suggesting a common origin. Astronomers believe that the Norse group of moons are remnants of a larger population of objects that once existed in the early solar system. These objects, known as planetesimals, were the building blocks of planets. As the giant planets formed, their gravitational influence scattered and captured many of these planetesimals. Farbauti and its fellow Norse group moons are thought to be survivors of this chaotic period, preserving a record of the early solar system's formation and evolution. Farbauti, despite its diminutive size and distant location, holds immense scientific significance. It belongs to a class of objects known as irregular satellites, which are characterized by their distant, often eccentric, and inclined orbits. These irregular satellites, unlike the large round moons that formed alongside their host planets, are believed to be captured objects. Farbauti's capture event and subsequent orbit around Saturn provide valuable clues about the dynamics of the early solar system. Farbauti's significance extends beyond its individual story. It serves as a representative of a population of objects that played a crucial role in the formation and evolution of giant planets like Saturn. Giant planets, with their immense gravitational pull, acted as cosmic vacuum cleaners in the early solar system, capturing smaller objects that ventured too close. These captured objects, including irregular satellites like Farbauti, contributed to the giant planet's growth and influenced their final compositions. By studying the composition of Farbauti, astronomers hope to gain insights into the building blocks that were available during Saturn's formation. Farbauti's dark reddish surface similar to that of many other outer solar system objects, holds clues about its composition and the processes that have shaped its surface over billions of years. The reddish hue is indicative of the presence of organic molecules, complex carbon-based compounds that are the building blocks of life as we know it. These organic molecules are thought to form through the irradiation of simple ices by solar radiation. The outer solar system, far from the sun's warmth, is a cosmic shooting gallery, where objects are constantly bombarded by micrometeoroids and energetic particles from the sun. Studying the effects of this space weathering on Farbauti's surface can help scientists understand the evolution of small bodies in the outer solar system. While Farbauti itself is not considered a prime candidate for hosting life, its composition and the processes that have shaped it are relevant to the broader search for life beyond Earth. The presence of organic molecules on Farbauti, along with the likelihood of water ice in its interior, highlights the widespread distribution of these key ingredients for life throughout the solar system. The study of objects like Farbauti helps scientists understand the conditions under which these ingredients can be preserved and potentially delivered to other bodies, such as the early Earth. Farbauti, therefore, serves as a reminder that even small, seemingly insignificant objects in the vastness of space can hold clues to the fundamental questions about the origins of life. Saturn, with its dazzling rings and retinue of moons, has long captivated astronomers. The quest to unravel the mysteries of this gas giant and its intriguing system has led to some of the most ambitious space missions in history. Among these, the Cassini-Huygens mission, a joint endeavor by NASA, ESA, and ASI, stands out as a landmark achievement. Launched in 1997, Cassini spent 13 years orbiting Saturn, sending back a treasure trove of data that revolutionized our understanding of this distant world. Cassini's instruments peered through the haze of Titan's atmosphere, revealing lakes of liquid methane and evidence of a complex organic chemistry. The spacecraft also observed geysers erupting from Enceladus, hinting at a subsurface ocean that could potentially harbor life. Although Cassini's observations of Farbauti were limited, they provided valuable data points in our understanding of this enigmatic moon. The spacecraft's images, combined with ground-based observations, allowed astronomers to refine estimates of Farbauti's size, shape, and orbital characteristics. These observations confirmed Farbauti's retrograde orbit, further supporting the idea that it was captured by Saturn's gravity rather than forming in its current location. The data also hinted at the moon's extremely dark surface, suggesting a composition rich in carbon-based compounds. Cassini's instruments, however, were not designed for detailed studies of small, distant objects like Farbauti. Unveiling the secrets of its composition, surface features, and potential for harboring water ice would require dedicated missions with more advanced instruments. While there are currently no dedicated missions planned specifically for Farbauti, future exploration efforts in the outer solar system could provide opportunities to study this distant moon in greater detail. As technology advances, new generations of spacecraft will be equipped with more sensitive instruments and capabilities, allowing them to probe the secrets of even the smallest and most distant objects in our solar system. These future missions might involve flybys of Farbauti, providing high-resolution images of its surface and potentially revealing geological features that could hint at its internal structure and history. Other possibilities include deploying small robotic probes to land on Farbauti's surface, collecting samples, and analyzing its composition directly. Such missions would represent a significant leap forward in our understanding of this enigmatic moon and its place in the grand tapestry of our solar system. Section 1. The Expanding Cosmic Story. For centuries, humanity's understanding of the cosmos was confined to the few thousand stars visible to the naked eye and the handful of planets in our solar system. Our cosmic story was limited, a narrative centered on a familiar cast of celestial characters. However, with the advent of powerful telescopes and sophisticated spacecraft, our cosmic horizons have expanded dramatically. We now know that our solar system is not alone, that billions of stars in our galaxy harbor their own planetary systems, many of which are stranger and more diverse than we could have imagined. This realization has profoundly shifted our perspective, pushing us to reevaluate our place in the grand cosmic scheme. The study of moons like Farbauti, once considered insignificant outliers, has taken on new importance in this era of cosmic exploration. These small icy worlds, once shrouded in mystery, are now recognized as valuable pieces in the puzzle of planetary system formation and evolution. Section 2. Farbauti's place in the cosmic play. Farbauti represents objects that hold clues to the early solar system, a time of planetary formation and gravitational interactions. Studying Farbauti helps astronomers understand planetary formation and the diversity of planetary systems. The capture of objects like Farbauti by giant planets was common in early planetary system evolution. Section 3. Unveiling the secrets of planetary formation. The study of Farbauti's orbit provides further insights into the dynamics of planetary system formation. Its retrograde orbit, in the opposite direction to Saturn's rotation, suggests that it did not form in its current location but was captured from a different region of the solar system. This capture event, and the subsequent evolution of Farbauti's orbit, can reveal information about the gravitational interactions that shaped the Saturnian system. Furthermore, the inclination and eccentricity of Farbauti's orbit, as well as its membership in the Norse group of Saturnian moons, provide clues about the potential mechanisms of its capture. These orbital characteristics suggest that Farbauti may have been part of a larger population of objects that were scattered inward from the outer solar system, perhaps during a period of planetary migration or instability. By studying the orbital properties of Farbauti and other irregular satellites, astronomers can refine models of planetary system formation and test different theories about the evolution of our own solar system. Section 1. A Universe of Moons. Our exploration of Farbauti, a small icy moon, reveals a story much larger than itself. It speaks to the intricate dance of gravity and our quest to understand the universe. Each new discovery adds a layer to our cosmic story. Moons are now recognized as dynamic worlds with unique stories. The study of moons is a cornerstone of modern astronomy. Section 2. Farbauti Beckons. While our current knowledge of Farbauti is limited, gleaned from fleeting glimpses through powerful telescopes and the legacy data of missions like Cassini, its allure remains strong. This small, icy world, holding clues to the formation of our solar system and the distribution of life's building blocks, beckons us to explore further. Each unanswered question, each tantalizing hint of its hidden depths, fuels the desire to unlock its secrets. Future missions to the outer solar system, equipped with advanced instruments and propelled by our insatiable curiosity, hold the key to unraveling Farbauti's enigmatic past. Imagine spacecraft specifically designed to study these small, icy worlds, capable of mapping their surfaces in high resolution, analyzing their composition in detail, and even peering beneath their icy crusts. Such missions, driven by the spirit of exploration that has defined humanity for millennia, would not only deepen our understanding of Farbauti, but also provide invaluable insights into the broader processes that govern planetary system formation and evolution. Section 3. The Uncharted Frontier. As we stand on the cusp of a new era of space exploration, the study of moons like Farbauti takes on added significance. These small icy worlds, once overlooked, are now recognized as potential harbors for life. Their subsurface oceans offer tantalizing possibilities, The discovery of even the simplest organisms would have profound implications. As we venture further into the cosmos, moons like Farbauti will continue to inspire new generations. The uncharted frontier of our solar system awaits.